Welcome to April 3rd, Kitchen Table Chemistry. What I'm going to try and teach you today is how to determine the order of a reaction and the rate reaction constant. In kinetics, this is going to be the law that governs how a reaction will run, its rate and its rate at different concentrations. So I'm going to go over pieces of this today. I'm going to try to keep it short. I've already tried to do it and it did not stay short enough. So did you know you can't upload a video to YouTube that is more than 15 minutes long? I now know this. All right, here we go. Rate law. The rate, which is going to be usually in molarity per second, and that rate, molarity per second, molarity now is square brackets equal to K. K is the reaction constant. The units on this is a whole separate lesson. This, which is the concentration of A, and here we have the concentration of B. And if we had a C thing, we would have the concentration of that. M here is the rate order of A, and N is the rate order of B. When combined, all of these things together will tell us how fast our rate, or what our rate of reaction will be. Okay, how to determine or find these things. So here we've run three different experiments. Experiment 1, Experiment 2, and Experiment 3. These things must be done experimentally. So we would have three experiments that we've run. Now notice in Experiment 1 and 2, we have changed the amount of A but kept the amount of B constant. This will allow us to not consider the rate of B or the concentration of B. And here we've got our rates for the two. So in order to find the rate order of A, what I'm going to do is take and compare two reactions, in this case experiment 2 and experiment 1, where A changes and B stays constant. So we're going to put experiment 2 and we're going to divide it by experiment 1. So this will equal the rate of 2 on the top and the rate of 1 on the bottom, and that will equal K over K, because each one would have K in its rate law. The concentration of A for the second experiment to its rate order, which is M, we don't know, divided by the concentration of A from the first experiment to its rate order, don't do that, which we don't know, and then B to its factor of N over B to its factor of N. M, there we go. So this will be B from the second, and this will be B from the first, and they will not change. All right. So now what we have here is we're going to have experiment 2 over experiment 1 is equal to the rate of 2, which is 8.0 times 10 to the negative third, divided by 4.0 times 10 to the negative third, that is the rate for the first experiment, is equal to K over K. Now we don't know what K is here, but we're okay because, no pun intended, but we're okay because K is going to cancel out. Anything written above itself always cancels out. The concentration of A from reaction number 2 is 0.10, and that's from reaction 2, and that would be 0.10 to the M, and that will be divided by 0.05, which is the concentration of substance A in reaction 1. Now substance B here will be 0.05 to the N divided by 0.05 to the N, because in both reactions 2 and reactions 1, they were exactly the same. So again, they will cancel out. So what we're now left with here, and this is again experiment 2 over experiment 1. These divided, 8 times 10 to the negative third divided by 4 times 10 to the negative third is going to equal 2. Is going to equal 2, which is 0.1 divided by 0.05, 2 to the m. So therefore, m equals 1. And what this is the rate order of A, substance A. So we figured out the rate order of substance A. So we know that that is 1. Now we're going to determine the rate order of substance B. In order to do this, we are going to do the same thing, only now we've got, we've got number reaction 1 or experiment 1, experiment 2, and experiment 3. All right, so now if we compare 1 and 3 here, and I'm just learning to use the pen here. I'm not too good with it yet. I'm going to change colors all completely because we're doing something different. We're going to compare, stop it. We're going to compare, I'll go back to that slide. That's what we want to do. So we're going to compare these two reactions because A doesn't change. Any change now is going to be due solely to B. So we're going to not take a look at reaction 2 at all this time. We're only going to take a look at 3 versus 1. So what we're going to take a look at here is what we did with experiment 3, and we're going to divide it over experiment 1. This will be equal to the rate in 3 over the rate 1 equal to K over K. Concentration of A, don't do that, concentration of A to the first, because we know that, over concentration of A to the first. This will be for the third experiment. This will be for the first. The concentration of B to the N for the third experiment over the concentration of B to the N for the first experiment. All right, now let's just fill in our values. So 1.6 times 10 to the negative second over 4.0 times 10 to the negative third is equal to K over K. Doesn't matter, they're the same for both, all three experiments. Now we have 0.05, which is our concentration of A from the third experiment, and that is to the first power, and 0.05, which is our concentration of A in the first experiment. Here we have now 0.10, which is N over 0.10, which is to the factor of N. And we'll do our math. 1.6 divided by 4, so that's going to be 4. Our K's cancel out, these cancel out, and I miswrote that entirely. Where is the eraser? Oh, good Lord. Eraser. If you were paying attention, and I know you were, this is for the third, and this is for the third, and this was for the first, so I should have put in 0.05. So 0.1 divided by 0.05 is going to equal 2. So what we have now is 2 to the n is equal to 4, and now n is equal to 2. That is the exponent it has to be in order to equal 4. So n to the second equals 4. And now we've found the rate order for B. So the rate order, stop it. The rate order for B is 2. Okay, I'm going to advance this slide now. Now we're going to find the value for K. We can choose any one of the three experiments that we want to. Either one or any one will work. So let's look at it this way. We've got 1, 2, and 3. And for no reason at all, we will choose number 1. So we will use all of this data, and we're going to find the value of K, this thing that we've been crossing out that we don't know. The rate law says rate is equal to K times the concentration of A to the first, the concentration of B to the second. We've figured out these rate orders for A and B. So all I need to do now is insert everything that I know, and I can come out with what the rate order is. So the rate is 4.0 times 10 to the negative 3 is equal to K times 0.05 to the first times 0.05, which is the concentration of B, to the second. And if I solve this now, I get a K value of 32. What you really want to do here is make sure you put everything here in parentheses when you go to divide. And try it a couple times till you come up with that answer that is 32. So that now, and I'm not going to worry about the units on this, but this is our rate constant. And that is pretty close to solving for an entire rate law. There's a few pieces and details that are missing, but let's face it, we're doing this from home. And I think if we can get to this point on our own, we'll be in pretty good shape. I'm going to give you one to practice over the weekend, and then what we'll do is I'll explore that example with you on Monday, and we'll go at it there and see how we did. If you can come up with the answers for that, please, and I believe you probably can. Again, take a picture of it, send it to me on Canvas. Let me see how you're doing. If you've got any questions or concerns, again, let me know how you're doing. I hope you have a great weekend. I hope if you still have to go out and work that you are able to do so safely and that you are treated well wherever it is that you are working. And I look forward to engaging with you guys again and doing this again on Monday. Have a great weekend. Take care. Bye-bye.